Introduction to Euclid's Geometry. Introduction. The word geometry comes from the Greek word geo, meaning the earth, and metrein, meaning to measure. Geometry appears to have originated from the need for measuring land. This branch of mathematics was studied in various forms in every ancient civilization, be it in Egypt, Babylonia, China, India, Greece, the Incas, etc. The people of these civilizations faced several practical problems which required the development of geometry in various ways. For example, whenever the river Nile overflowed, it wiped out the boundaries between the adjoining fields of different landowners. After such flooding, these boundaries had to be redrawn. For this purpose, the Egyptians developed a number of geometric techniques and rules for calculating simple areas and also for doing simple constructions. The knowledge of geometry was also used by them for computing volumes of granaries and for constructing canals and pyramids. They also knew the correct formula to find the volume of a truncated pyramid. So, you know that a pyramid is a solid figure, the base of which is a triangle or square or some other polygon, and its side faces are triangles converging to a point at the top. In the Indian subcontinent, the excavation at Harappa and Mohenjo-daro, etc., show that the Indus Valley civilization about 3000 BCE made extensive use of geometry. It was a highly organized society. The cities were highly developed and very well planned. For example, the roads were parallel to each other and there was an underground drainage system. The house had many rooms of different types. This shows that the town dwellers were skilled in mensuration and practical arithmetic. The bricks used for construction were kiln-fired and ratio length, breadth, thickness of the bricks was found to be 4:2:1. The bricks used for construction were kiln-fired and the ratio length is to breadth is to thickness is to thickness of bricks was found to be 4:2:1. In ancient India, the Salva Sutras 800 BCE to 500 BCE were the manuals of geometrical constructions. The geometry of the Vedic period originated with the construction of altars or Vedis and fireplaces for performing Vedic rites. The location of the sacred fires had to be in accordance to the clearly laid down instructions about their shapes and areas if they were to be effective instruments. Square and circular altars were used for household rituals, while altars whose shapes were combinations of rectangles, triangles, and trapeziums were required for public worship. The Sriyantra given in the Arthashastra consists of 9 interwoven isosceles triangles. These triangles are arranged in such a way that they produce 43 subsidiary triangles. Though accurate geometrical methods were used for the construction of altars, the principles behind them were not discussed. These examples show that the geometry was being developed and applied everywhere in the world, but this was happening in an asymmetric manner. What is interesting about these developments of geometry in the ancient world is that they were passed on from one generation to the next, either orally or through palm leaf messages or by other ways. Also, we find that in some civilizations like Babylonia, geometry remained a very practical oriented discipline, as was the case in India and Rome. The geometry developed by Egyptians mainly consisted of the statements of results. There were no general rules of the procedure. In fact, Babylonians and Egyptians used geometry mostly for practical purposes and did very little to develop it as a systematic science. But in civilizations like Greece, the emphasis was on the reasoning behind why certain constructions work. The Greeks were interested in establishing the truth of the statements they discovered using deductive reasoning. A Greek mathematician, Thales, is credited with giving the first known proof. This proof was of the statement that a circle is bisected, that is, cut into two equal parts by its diameter. One of Thales' most famous pupils was Pythagoras, whom you have heard about. Pythagoras and his group discovered many geometric properties and developed the theory of geometry to a great extent. This process continued till 300 BCE. At that time, Euclid, a teacher of mathematics at Alexandria in Egypt, collected all the known work and arranged it in his famous treatise. Now, Euclid's definitions, axioms, and postulates. The Greek mathematicians of Euclid's time thought of geometry as an abstract model of the world in which they lived. The notions of point, line, plane, or surface, and so on were derived from what was seen around them, from studies of the space and solids in the space around them. An abstract geometrical notion of a solid object was developed. A solid has shape, size, position, and can be moved from one place to another. Its boundaries are called surfaces. They separate one part of the space from another and are said to have no thickness. The boundaries of the surfaces are curves or straight lines. These lines end in points. Consider the three steps from solids to points. In brackets, solid surfaces, lines, points. In each step, we lose one extension, also called a dimension. So, a solid has 3 dimensions, a surface has 2, a line has 1, and a point has none. Euclid summarized these statements as definitions. He began his exposition by listing 23 definitions in Book 1 of the Elements. A few of them are given below. 1. A point is that which has no part. A line is breadthless length. The ends of a line are points. A straight line is a line which lies evenly with the points on itself. A surface is that which has length and breadth only. The edges of a surface are lines. 7. A plane surface is a surface which lies evenly with the straight lines on itself. If you carefully study these definitions, you find that some of the terms like part, breadth, length, evenly, etc. need to be further explained clearly. For example, consider his definition of a point. In this definition, a part needs to be defined. Suppose if you define a part to be that which occupies area, again an area needs to be defined. So, to define one thing, you need to define many other things, and you may get a long chain of definitions without an end. For such reasons, mathematicians agreed to leave some geometric terms undefined. However, we do have an intuitive feeling for the geometric concept of a point than what the definition above gives us. So, we represent a point as a dot even though a dot has some dimension. A similar problem arises in dimension 2 above since it refers to breadth and length, neither of which has been defined. Because of this, a few terms are kept undefined while developing any course of study. So, in geometry, we take a point, a line, and a plane as undefined terms. The only thing is that we can represent them intuitively or explain them with the help of physical models. Starting with his definitions, Euclid assumed certain properties which were not to be proved. These assumptions are actually obvious universal truths. He divided them into two types, axioms and postulates. He used the term postulate for the assumptions that were specific to geometry. Common notions, often called axioms, on the other hand, were assumptions and used throughout mathematics and not specifically linked to geometry. Some of Euclid's axioms not in his order are given below. Things which are equal to the same thing are equal to one another.